Welcome. In this video, I'm going to show how to use calculus to identify the horizontal asymptotes of a function. In this case, we want to identify the horizontal asymptotes of g of x, and g of x is equal to the square root of 3x squared minus 1 divided by 2x minus 5. So we want to find the limit as x approaches infinity of g of x, so that's 3x squared minus 1 divided by 2x minus 5. Additionally, we're going to find the limit as x approaches negative infinity, but let's begin here. Now we need to multiply our numerator and denominator by a value, and that value is the x value with the highest power in the denominator. So that is x. Dividing this entire denominator by x is equivalent to multiplying by 1 over x. So let's go ahead and do that for our numerator and our denominator. So in my denominator, I just distributed 1 over x across both of these terms. My numerator is going to take a little bit more work, so let me do that here on the side. Now, since I'm approaching positive infinity, that is, x is approaching positive values of infinity, I can rewrite this as 1 over the square root of x squared times the square root of 3x squared minus 1. This gives me the square root of 3x squared minus 1, and each of these quantities divided by x squared. This entire quantity divided by x squared, which is just 3x squared over x squared minus 1 over x squared. Simplifying, I get the square root of 3 minus 1 over x squared. Okay, so let's replace that in our numerator. I also went ahead and simplified 2x over x as just 2. Now, as x approaches infinity, this becomes 0. That is, the limit as x approaches infinity of negative 1 over x squared is equal to 0. And the limit as x approaches infinity of negative 5 over x also equals 0. So I am left with the limit as x approaches infinity of the square root of 3 over 2, which is just the square root of 3 over 2. All right, so now let's take a look at the limit as x approaches negative infinity of the square root of 3x squared minus 1 over 2x minus 5. So we're going to do the same little algebra trick. That is, I'm going to multiply both my numerator and my denominator by 1 over x. Now for this case, our numerator is going to be a little bit different. Since x is approaching negative infinity, I know that my values of x are less than 0, whereas in the previous case they were greater than 0. Since by definition the square root of x squared is the absolute value of x, and the absolute value of x being a piecewise function, which is x if x is greater than or equal to 0, and negative x if x is less than 0. This means that the square root of x squared in our case is going to be negative x, since our values of x are less than or equal to 0. All right, so how does this affect us? Well, rather than having 1 over the square root of x squared, we actually need 1 over negative times the square root of x squared, and that's being multiplied to 3x squared minus 1. So we end up with negative 3x squared minus 1 in the root divided by x squared, which simplifies to negative 3x squared over x squared minus 1 over x squared, or negative square root of 3 minus 1 over x squared. So let's go back to our limit problem. We have the limit as x approaches negative infinity. In our numerator, we have negative square root of 3 minus 1 over x squared, and then we're dividing this by 2 minus 5 over x. Now, similarly to what happened above, this limit is 0, and this limit here is also 0. That is, the limit as x approaches infinity of negative 1 over x squared is 0, and the limit as x approaches infinity of negative 5 over x is also 0. So we end up with the limit as x approaches negative infinity of negative root 3 over 2, which is negative root 3 over 2. So this function has a horizontal asymptote at y equals root 3 over 2, and another and 1 at y equals negative root 3 over 2. Now this would be a good time to point out that even though functions cannot cross their vertical asymptotes, so if I have a vertical asymptote here, a function will never cross it. Functions can cross their horizontal asymptotes. So this is a horizontal asymptote. My function could go up here and then kind of settle in to getting very close to the asymptote. I hope this video was helpful.